Hi everyone, today we'll be looking into LLM fine tuning. So, this will be a series of episodes wherein today we are looking into what LLM fine tuning is and why do we need it. So, this is our base model which is trained on internet data. General LLM is a jack of all trades but master of none. So, if we have a pretty specific task, for example, related to healthcare industry or legal proceedings, our LLM will provide a generic response. To overcome this, we have two methods. One is to use RAG, about which we have already studied in detail. In RAG, we confine the model's context by providing use case specific data. The other one is fine tuning, wherein we retrain the complete pre trained LLM over use case specific data. Now, you must be wondering, when we have RAG, why do we need fine tuning? Where does RAG basically fails? In our RAG series, we talked about lost in the middle phenomena, but it had a solution called re-ranking, right? Also, when we use RAG, we just change the context. The outputs will still be in the language of the base LLM. So for language personalization, we use fine-tuning. Next is format fragility. Base LLM models are built to generate language, basically to carry out NLP task. But suppose you just need your answer to be in JSON format. Now you must be thinking that I'll instruct the LLM to use JSON format in the prompt itself. But let's say 8 out of 10 times your model will succeed. Still, what about those two, where it will still generate language and not JSON response? The most important one is latent gap. As we discussed in RAG, we are just modifying the context. The trained model remains the same. So, for example, you're using LM at a hospital and you use HDX, which is basically hemodialysis. So, your RAG system would probably hallucinate if this is not explicitly mentioned in the RAG data. So, the question is when to use and what are the differences between RAG and fine tuning. The rule of thumb is pretty straightforward. If you think knowledge is the issue, use RAG. Whereas if behavior is the problem, then use fine tuning. Let's walk through some differences between them. So RAG is non-parametric or it is external. Basically, we train it from external data. Whereas fine tuning is parametric or internal to the model. RAG has limited context. Whatever documents you provided becomes its context. Whereas fine tuning has infinite context for things it learns. RAG is perfect for finding the right page, but it might fail at complex reasoning. Like if we need something inside that page, RAG might fail. Whereas fine tuning is perfect for reasoning, but it might forget data like some numbers from last Tuesday. Hence, a hybrid model consisting of both RAG and fine tuning works the best, wherein we'll be using RAG for finding context and fine tuning for reasoning. Let's look into basics of fine tuning now. So basically, this is a three-step job. The first step being supervised fine tuning. Here we teach the model what exactly to do with the prompts which are given to it. Then alignment or training. Here we show model two answers, one chosen and one rejected, and it learns patterns to favor the higher quality output. What is the specific technique called? So if you said reinforcement learning, you are probably wrong because it is DPO or direct preference optimization. Do let me know in the comments the difference between RLHF and DPO. We'll be looking into this in detail in upcoming videos. The third step is task specialization or preparing the model for the niche it will be used for. Now there are types of fine tuning. The first one is full fine tuning, which is to retrain around 70 billion parameters a game. And then there is parameter efficient fine tuning, where we play just with the head layers. So that's all for this introductory episode. In the upcoming ones, we'll be deep diving into these fancy terms which we learned today. Until then, keep learning.